Alright guys, welcome back to another video. And now we're working question 10 from the June 2018 Mathematics Paper 2. So thank you for staying with us so far. So question 10 starts by saying a transformation T is defined by the matrix T is equal to 2, negative 1, 2, 0. The point A, which is negative 2, 3, is mapped onto the point A prime, which is AB, under the transformation, under T, which is the transformation which is given above. So it says find the value of A and of B, which are the points for the image. So what we know is that we'll have the transformation being multiplied by the point, which is negative 2, 3, to give us the point A prime, which is A, and B. So what we'll have is row against column, and then row against column. So we'll have 2 multiplied by negative 2. So we'll have 2 multiplied by negative 2, and then negative 1 multiplied by 3. And then we'll have 2 from here multiplied by negative 2, and then 0 multiplied by 3. And that's how we get 2 multiplied by negative 2 plus negative 1 multiplied by 3, and 2 multiplied by 2 and 0 multiplied by 3 to give us AB. And this is what we're working on. So when we do 2 multiplied by negative 2, we get a negative 4 plus a negative 1 multiplied by 3 to give us a negative 3. And then 2 multiplied by negative 2 to give us a negative 4 plus 0 multiplied by 3 to give us 0. And we can now complete this matrix and we'll get the corresponding values for A and B. So a negative 4 plus a negative 3 will give us a negative 7, and a negative 4 plus 0 will give us a negative 4. And these are the corresponding values for A, B. So A is equal to a negative 7 and B is equal to a negative 4. So the value for A and of B is negative 4, negative 7, and negative 4 respectively. Two now says determine the transformation matrix that maps A prime to A. So we're looking at what is a transformation matrix. So what we need to do is find the inverse of the original matrix that was given. So it will give basically from the, working from the image to the object, so it will give the opposite of that. So we need to find the inverse. So T inverse. So T was given as 2, negative 1, 2, 0. So T inverse will give the matrix that maps A prime to A. So first we need to find, when we're looking at inverse, we need to find the determinant of the matrix. So what we're doing is multiplying the diagonals and subtracting them. So we're doing 2 multiplied by 0 minus 2 multiplied by negative 1. So it becomes 2 multiplied by 0 to give us 0 minus 2 multiplied by negative 1 to give us negative 2, and therefore the determinant is a positive 2. So now looking at the inverse, it will be the determinant multiplied by the matrix. So what we do is we switch the main diagonal, the positions of the terms in the main diagonal, and change the sign on the other diagonal. So this, instead of having a 2, 0, we flip it to have a 0, 2, and then change the sign on the other diagonal. So this becomes a positive 1 and this becomes a negative 2. So now 0 divided by, half multiplied by 2, which is 0 divided by 2, 1 divided by 2, negative 2 divided by 2, and 2 divided by 2. What we'll get is 0, a half, negative 1, and 1. So it's multiplying a half by each term in the matrix. And this is our answer for the transformation matrix that maps A prime to A. Part 3 now says another transformation P is defined by the matrix P is equal to 0, 1, 1, and negative 2. So it says find the single 2 by 2 matrix that represents the combined combination of T followed by P. So when it says T followed by P, what it means is that T is being done first, followed by P. And this will be written as PT. So we have T from the previous part of the question, which is 2, negative 1, 2, 0. So T followed by P will be represented as PT. So if we're now looking for the matrix, which is the combined transformation of T followed by P, we're multiplying the matrix. So what we'll have is row by column, row by column. So row by column, then row by column, row by column. So what we'll have is 0 multiplied by 2 for right here, then 1 multiplied by 2. And then 0 multiplied by negative 1 for right here, and 1 multiplied by 0 for right here. And then 1 multiplied by 2 for right here, and negative 2 multiplied by 2 for right here. Then 1 multiplied by negative 1 for right here, and a negative 2 multiplied by 0 for right here. And now it's just basic addition and subtraction, multiplication to complete our matrix. So 2 times 0 will give us 0, and 1 times 2 will give us 2. 0 multiplied by negative 1 will give us 0, and 1 multiplied by 0 will give us 0. 1 multiplied by 2 will give us 2, and a negative 2 multiplied by 4 will give us a negative 4. 1 multiplied by negative 1 will give us negative 1, and a negative 2 multiplied by 0 will give us 0. And then we go ahead and do a regular addition. So 0 plus 2 is 2, 0 plus 0 is 0, 2 minus 4 is negative 2, and negative 1 plus 0 will give us a negative 1. And this is the combined transformation of T followed by P. So this is a 2 by 2 matrix that represents the combined transformation of T followed by P. So part B now says, hence find the image of the point 1, 4 under this combined transformation. So we have PT, which was 2, 0, negative 2, 1. And our image will be represented by multiplying T by this point, PT by this point 1, 4. So it will be row by column, then row by column. So what we have is 2 multiplied by 1, 0 multiplied by 4. Then negative 2 multiplied by 1, negative 1 multiplied by 4. So what we'll get is 2 multiplied by 1 is 2, 0 multiplied by 4 is 0. Negative 2 multiplied by 1 is negative 2, and negative 1 multiplied by 4 is a negative 4. So we now go ahead and work our matrix. So what we'll get is 2 plus 0 is 2, and negative 4 plus negative 2 plus negative 4 will give us a negative 6, and this is our image. So this is the image of the point 1, 4 under the combined transformation, which is PT. Part B now says the diagram below not drawn to scale shows a quadrilateral ABCD, which the magnitude AB is equal to M, DC is 3M, and AD is N. So AB right here is M, DC is 3M, and AD is N. And it says complete the statement below on the geometric properties of the following vectors. So vector AB and DC are, so AB and DC, based on the direction in which they're going and they're positioned, what we know that AB and DC are parallel. and for the length of AB. So what we know is that it says that what we're seeing is that DC, AB is M and the DC is 3 times M, which means that DC is 3 times the length of AB, which means that then AB is 1/3 times the length of CD. So when we do 1/3, 1/3 times 3M will get the length of AB. So part 2 says express BC, so BC in terms of M and N. So going in this direction so that we can get to D, what we see is that BA plus AD plus DC will give us the answer for BC. If we're looking now, the direction AB was going in this direction. So now if we're looking at BA, this M will now take on a negative sign. So therefore, as it were now going in the opposite direction relative to what AB was going in, we're now going from B to A. So we're going in the opposite direction, which is unconventional to what is being done there. So therefore, we'll get a negative M here plus N. A to D is represented by N, and D to C is represented by 3M. We can group our like terms and then go ahead to simplify. So a negative M plus 3M plus N. So a negative M plus 3M will give us 2M plus N, and this is us expressing BC in terms of M and N. So BC is 2M plus N. Part 3 now says L is the midpoint of CD, and it says find BL, so from B to L in terms of M and N. So again, we're going in this direction from B to reach to L. So BL would then be BA plus AD plus DL. And we know again our M here will take on a negative sign, so it will be a negative M plus N, which is AD. And what we know is that L is the midpoint of DC, and the length of DC was 3M, or the magnitude of DC was 3M. So therefore, if L is the midpoint on DC, it means that DL would be half of 3M. So if we now work out grouping our like terms, we'll have negative M plus half of 3M plus N. If we now work out half of 3M, we'll get minus M plus 1.5, as 3 divided by 2 is 1.5 M plus N. So now in further simplifying, minus M plus 1.M will leave us with a 0.5 M plus N, which is the same as BL is equal to half M plus N. And that is our answer for writing the vector BL in terms of M and N. And that is the end of our question 10 and the 2018 Mathematics Past Paper 2. Thank you for joining us, and we'll see you in another video.